High-performance, low-latency production trading and risk management systems are currently dominated by C++. However, as software engineers increasingly adopt Rust across various industries, I wonder, will quantitative development pivot to Rust in the near future? In this video, I'll explore the current landscape and provide a proof-of-concept Rust trading project which you can try doing yourself. Quantitative research is typically conducted in high-level languages like Python. This allows researchers to focus on algorithmic prototyping. These prototypes are then translated into C++ for execution. C++ remains the undisputed standard in high-frequency trading, driven by its unparalleled bare metal control and decades of hyper-optimized compiler maturity. Rust matches C++ in raw execution speed but introduces an all-new advantage: compile-time memory safety. Its borrow checker mathematically eliminates catastrophic runtime errors such as segmentation faults, memory leaks, and data races without the latency tax of a garbage collector. This ensures safer multi-threaded architectures and makes a strong case for Rust as a modern alternative. The primary hurdle is the sheer amount of legacy infrastructure. Hedge funds have spent decades hyper-optimizing C++ libraries and critical software, meaning a full rewrite offers no immediate financial return while introducing immense operational risk. Integrating Rust's cargo package manager into massive enterprise-level C++ build systems create substantial friction. The industry also faces a shortage of experienced Rust developers and resistance from senior developers who have become used to established C++ workflows. Rather than attempting to rewrite everything, firms are adopting hybrid approaches through a segmented architecture. C++ is strictly retained for nanosecond critical execution loops, while Rust is taking over the surrounding infrastructure. These are high-throughput data engineering pipelines, backtesting frameworks, and complex machine learning simulations. This shift has created a divide in the industry. Traditional proprietary trading firms remain deeply entrenched in C++. Rust is becoming more common in, for example, the crypto sector, where firms lack legacy technical depth and require Rust's strict memory safety as a mandatory security requirement to prevent devastating financial exploitation. Mastering both languages and understanding where the boundary between use cases go is becoming the new gold standard for quantitative developers. To demonstrate Rust's utility in quantitative finance, I created a Monte Carlo simulation to estimate the value of pi using the plotters library to visualize the results. This proof of concept shows you how one can begin building quantitative tools in Rust today, providing a competitive edge in the evolving job market. Here are the steps to replicate the Monte Carlo simulation. Import the plotters library. Use the result in main to automatically handle failures. Set the sample size, which is the amount of dots to use. Generate a list of random values for both the x and y axis. Set up the chart. Define the 2D Cartesian area, minus 1.0 to 1.0 on both axes. Separate all your coordinates into those within the 0.5 radius circle and those outside it. Draw the dots within the circle as red and those outside the circle as blue. Write the chart to a file. Do the actual pi estimation by dividing the points inside the circle by the total sample size and multiply by 4. Print the estimate and the error of the estimation into the console. The full source code is linked in the description. C++ will not be unseated from the ultra-low latency core trading engines anytime soon, but Rust is rapidly becoming the language of choice for all surrounding high-throughput quantitative infrastructure. By guaranteeing memory safety at compile time and providing robust concurrency primitives, Rust eliminates the most common sources of catastrophic failures in low-latency systems, while enabling the development of more reliable and productive applications. Thank you for watching. Please comment your opinions on the matter. I'd be interested to understand other viewpoints.